Crash Course Instrumentation. Diagnostics. Episode 1. What is diagnostic thinking? Welcome to Crash Course Diagnostics, a brand new series from Crash Course Instrumentation. Today we're kicking things off with one big question. What does it really mean to think like a diagnostician? If you've ever had to fix a malfunctioning circuit, track down a dead sensor, or troubleshoot why a system won't start, this skill isn't just helpful. It's essential, and it's in short supply out in the field. In this episode, we'll break down what diagnostic thinking really is, why it's more than just knowledge, and how you can start training your brain to troubleshoot like a pro. Let's dive in. What is diagnosis really? The word diagnosis comes from Greek, dia, meaning apart, and gnosis, meaning to know. So to diagnose something means to separate truth from assumptions, to uncover what's actually causing a problem and rule everything else out. Unlike solving a math problem or running a test procedure, diagnosis means you're starting with unknowns. You don't know what's broken. You don't know where the fault is. And your tools? They're not just meters and diagrams, they're your observation, patience, and logical thinking. Anyone can learn this skill. Some texts say diagnostics is a gift. You're either born with it or you're not. That's wrong. Every single student in tech gets better at diagnosis through practice. Because it's not magic. It's pattern recognition, guided by the scientific method. You observe, hypothesize, test, and narrow things down. And you do it efficiently, because time matters. How diagnostic thinkers think. Before you pick up your multimeter, ask yourself 3 essential questions. 1. What is it supposed to do? 2. What is it doing now? 3. When did things change? These questions set the foundation for any successful diagnostic process. Let's break it down with an example. Imagine a simple lamp circuit. The lamp won't light. Now, you could start checking everything at random. Is it the lamp? The switch? The wires? Maybe the fuse? But a diagnostic thinker does something different. They test one point and use the result to cut the problem space in half. They divide and conquer. They test again and again. And they don't guess. They let the evidence lead them. That's diagnostic thinking in action. It's about logic, not just circuits. Here's a twist. Diagnostic reasoning isn't limited to electronics. It shows up in software debugging, in process troubleshooting, even in medical exams. Anytime you face a system that isn't behaving as it should, and you need to isolate the root cause, you're doing diagnosis. So we'll treat this like a skill set, not just a topic. And over the next few episodes, you'll build your diagnostic muscles the same way you'd train for any technical challenge. Famous diagnostic minds. History is full of incredible diagnosticians. One of the most famous is Dr. Joseph Bell, a Scottish surgeon in the 1800s. He amazed students by diagnosing people's occupations and injuries just by observing how they moved, dressed, or held their tools. Sound familiar? He was the inspiration for Sherlock Holmes. In industrial work, the best troubleshooters use that same mix of deep knowledge, observation, and logic to diagnose problems others miss. Whether it's a failing transmitter or a plant that's lost its mind, great diagnosticians think like detectives. Real-world payoff. In the real world, diagnostic thinking saves you time, money, and sometimes lives. A blown fuse might hide a deeper short. A motor that's just hot could be on the verge of failure. A dead sensor might be caused by a missing ground. Not the sensor at all. Diagnostic thinkers don't just find problems, they understand them. And they fix systems faster because they know how to think like systems behave. Coming up next, in our next episode, we'll explore real-world opens, shorts, and voltage clues in failed systems, but through a diagnostic lens. Until then, keep thinking clearly, keep testing your assumptions, and remember, diagnosis isn't about knowing everything. It's about knowing how to find out what matters. Like, share, and subscribe for more episodes from Crash Course Diagnostics. A big thank you to Tony Kuphaldt and the open source community behind the Model project at ebiblio.org. See you next time.